Graphene chips have the potential to power electronics and build highly efficient batteries. Graphene microchips have the potential to increase the speed of telephones, computers, and other electrical devices by hundreds of times. Graphene with its nanoscale size have the potential to be utilized to produce the world's smallest microchips. The electrical properties of graphene were found by folding it like origami paper. Physicists found that graphene strips folded in the same way as origami paper may be used to make microchips that are up to 100 times smaller than ordinary chips, and that filling phones and laptops with such tiny chips might significantly improve the performance of our devices. Changing the structure of nanomaterials like graphene reveals electrical properties and essentially allows the material to serve as a transistor. This form of technology, known as straintronics, which uses nanomaterials rather than electronics, allows for more chips to be housed within any device. Everything we want to do with computers, such as accelerate them, can be performed by crinkling graphene in this way. Graphene, discovered in 2004, is an atom-thick sheet of carbon atoms that is effectively a 2D material due to its nano-sized width. Graphene is well known for its incredible strength, but it also boasts exceptional conductivity properties that have caught the curiosity of the electronics industry. Straintronics has already shown that deforming the structure of 2D nanomaterials like graphene, but also molybdenum disulfide, can expose important electrical properties. However, the behavior of such materials holds immense potential for high-performance devices. For example, changing the structure of a strip of 2D material may change its doping properties, which correspond to electron density, turning the material into a superconductor. They create structures out of graphene and other 2D materials by kinking the structure purposefully. They use this form of corrugation to create a complex electrical component, such as a transistor or a logic gate. Because of the utilization of these nanomaterials, computer processors will be smaller and faster. This is critical because computer manufacturers have hit the limit of what ordinary semiconducting technology can deliver. This will eventually result in computers and phones being hundreds of times faster. When particular distortions are folded into graphene, it behaves like a transistor, an electronic building unit. When a graphene strip is folded in this manner, it behaves like a microprocessor. The graphene component, on the other hand, is approximately 100 times smaller than conventional microchips. Graphene is a one-atom thick gauze of carbon atoms that resembles chicken wire and is made from the same raw materials as pencils. It has been dubbed new silicon because experts believe it holds the key to smaller, faster electronics as well as quantum mechanical processes that might enable new sorts of electronics. Until recently, most researchers could only make tiny graphene devices one at a time on ordinary silicon oxide substrates. They had no control over the placement of the devices on the substrate and had to connect them to other circuits one at a time for testing. Researchers have developed a revolutionary method for stamping several graphene sheets onto a substrate at the same time at precise places. Researchers have shown that a single sheet of graphene, as thin as a few tenths of a nanometer, or even a few sheets, may exhibit unique properties. One such characteristic is extremely high mobility, which allows electrons to pass through it very quickly, making it excellent for fast electronics. Magnetism is another example, since magnetic fields might be used to change the spin of graphene electrons, enabling spin-based electronics, also known as spintronics. When graphene comes into touch with other materials, its properties change dramatically, making it a great prospective material for chemical sensors. During the initial experimental run, the researchers were able to print high-definition details 10 layers deep or thicker. The graphite stamp may then be used again on other predetermined areas on the same or various substrates, potentially turning this into a mass production method. They want to someday stamp tiny features that are just 1 or 2 layers thick by stamping on materials other than silicon oxide. Computer simulations also indicated that each chemical reacts differently with graphene. So success may depend on determining the best combination of substrate materials to drive graphene to break off in 1 or 2 places. This would also alter the graphene's characteristics. Clean, limitless power from graphene. Physicists have created a circuit that can transform the thermal motion of graphene into an electrical current. A graphene-based energy harvesting circuit might be included on a chip to deliver clean, limitless low-voltage power to tiny devices or sensors. Freestanding graphene, a single sheet of carbon atoms, ripples and buckles, indicating that it may be used to capture energy. The thermal motion of graphene produces alternating current, AC, in a circuit, which was previously considered to be impossible. The circuit was designed by the researchers by converting alternating electricity to direct current using 2 diodes, DC. When the diodes are in opposition, enabling current to flow in both directions, they provide separate paths across the circuit, providing a pulsing DC current that works on a load resistor. They recognized that by enhancing their design, they might provide more power. They also discovered that the on-off, switch-like operation of the diodes actually boosts rather than decreases the power produced, as previously thought. The rate of resistance change provided by the diodes adds another component to the power. The researchers used a relatively new part of physics to show that the diodes increased the circuit's power. They relied on the nascent science of stochastic thermodynamics to demonstrate this power gain, and they expanded on an almost century-old, well-known hypothesis. The researchers also discovered that graphene's relatively slow motion creates current in the circuit at low frequencies, which is important from a technical viewpoint since electronics operate better at lower frequencies. The next objective is to store the DC current in a capacitor for later use, which requires miniaturizing and patterning the circuit on a silicon wafer, or chip. Millions of these little circuits might be built on a tiny chip and used to replace low-power batteries. Graphene chips will replace silicon. Researchers have developed a new generation of CPUs that are 1,000 times faster than the fastest processors available today while consuming only 1% of the power. It seems too good to be true, doesn't it? Let's start with transistors, which are vital in today's computer circuits because they act as on/off switches, enabling electronic signals and electrical power, referred to as binary bits, to flow through. These are microprocessors that allow you to solve logic and computing problems. This is now happening on the device you're using to watch this video. Silicon transistors have been utilized to manufacture microprocessors since March 1971. Microprocessor designers have become rather adept at exploiting silicon to produce CPUs, but the pace of signals and power that those transistors can handle is limited due to material resistance. Because silicon has reached its limits in terms of giving the exponential performance that we expect from a CPU. Researchers had been looking for new materials to serve as an alternative to graphene until they discovered it. Carbon atoms are structured in a hexagonal lattice 1 atom thick to form graphene. It is a graphite building component used in pencil tips. With a thickness of 1 atom, graphene is the thinnest substance known to man, yet it is also tremendously strong, 200 times stronger than steel. Graphene is also an excellent heat conductor, and it has fascinating absorption characteristics. It truly is a material with the potential to alter the world, with essentially endless uses in almost every industry. Researchers working on transistor-based logic circuits recently raised the clock speed of microprocessors by 1,000 times while consuming 1/100th the power required by silicon-based computers. Furthermore, these circuits were smaller than silicon transistor-based logic circuits. This might lead to smaller electrical devices with far more capabilities. In a similar work, graphene was explored as a viable capacitor for quantum computers. You may also see our movie about quantum computers by clicking here. Until February 16, 2021, research and development to replace silicon with graphene was moving quickly. The initial graphene discovery was made by a scientist at the University of Sussex in the United Kingdom. He created the world's smallest microprocessor using a method known as Nano-Origami. Nano-Origami is a sort of origami that is made by wrinkling or corrugating nanomaterials like graphene. Researchers discovered that when graphene is played in this fashion, it behaves like a miniature microprocessor by crinkling. The researchers devised a way for producing microchips that are 100 times smaller than standard ones. Graphene was already being considered as a silicon processing replacement. Because many major chip makers, including Qualcomm, Apple, and AMD, are nearing silicon limitations, this discovery has added a few to an already moving technology. Because graphene is such lovely stuff with endless possibilities. Why haven't we seen more graphene applications in the real world, and why has it suddenly gained popularity? Graphene manufacturing was not commercially viable since the costs outweighed the advantages. However, over the last 5 years, firms have put millions of dollars into R&D and try to make crafting that is both stable and inexpensive to produce. Flash graphene is one method of producing graphene. Rice University created a process in 2020 that uses a flash of light and heat to convert anything containing carbon, including abandoned food and plastic, into graphene. In 10 milliseconds, flash graphene converts any carbon source into a useful 2D material. This discovery piqued the interest of nearly every tech manufacturing corporation in developing at least some graphene-related research and development projects. This is why it developed in popularity so quickly. Next-generation computing gadgets using graphene microprocessors will revolutionize the tech industry in terms of battery life and performance. Energy generation and storage with graphene. Energy generation is one area where graphene might flourish since so many of its properties, such as electrical conductivity, would be useful. Graphene has the potential to be used in the development of more adaptive solar panels. The most efficient solar panels on the market now range from 20 to 25% efficiency. Scientists have discovered, however, that graphene absorbs photons from a larger spectrum of sunlight. These absorbed photons generated a large number of electrons, suggesting a potential efficiency of more than 60%. The ability to use graphene, according to MIT researchers, enables truly flexible low-cost, transparent solar cells that can turn practically any surface into a source of electrical power. Of course, once you've created all that wonderful electrical energy, you must either use it immediately or discover a way to store it. Graphene has already been used to improve recharge time, reportedly 15 minutes, and capacity, up to 10 times that of lithium batteries, supercapacitors, and supercapacitor battery hybrids. Holy graphene, a unique graphene-based material developed by UCLA researchers, allows for the creation of a capacitor with 10 times the energy density of currently available supercapacitors. Another group is working on a graphene gel saltwater battery, according to a report. According to the article, batteries based on this technology should charge faster, last longer, and maybe endure forever. The project's long-term goal is to have 3 full production batteries ready for launch. Making graphene from trash. We waste a lot of food. You've probably heard the statistics. The United Nations estimates that more than 1/3 of all food produced in the world is wasted. But what if you could turn trash into graphene? This notion is akin to Mr. Fusion from Back to the Future, except that scientists have developed a method for transforming nearly any chemical into valuable graphene. If you're not familiar with graphene, it's been referred to as a miracle material. It's only a thin layer of graphite, yet it's one of the toughest materials in the universe. It is, in reality, 200 times stronger than steel, but how did this wonder material emerge from trash? To begin, the researchers sandwiched the source material, which might be anything carbon-based, between 2 electrodes. A quick electrical pulse is then delivered to the material, immediately heating it to roughly 3000 degrees Celsius. Non-carbon components are either distilled or sublimated away, leaving just carbon. Then, when it cools, it reconstructs to become graphene, which is the most thermodynamically stable form of carbon. The entire process takes around 10 milliseconds. That is why scientists call it flash graphene. This is one of those by-chance discoveries. While one of the researchers was working with carbon, the technique was developed. Graphene may cost up to $200,000 per ton, but the flash graphene process is cheap and simple. This may be accomplished with nearly any raw material, not just food waste. The great thing about this for the environment is that much of the garbage we produce as humans is made of carbon, thus we consume carbon. All of our plastic bottles and plastic are made from carbon. We can now transform plastic waste into graphene for about $100 in electricity per ton. It is feasible to boost the strength of concrete by 35% by inserting less than 1% flash graphene. As a consequence, less concrete is utilized during building, which reduces the carbon footprint. Cement manufacture accounts for up to 8% of man-made carbon dioxide emissions, and the environmental benefits don't stop there. Instead of burning coal, flash graphene provides a more environmentally friendly application for it, as well as a use for goods that would otherwise wind up in a landfill. You may be wondering what happened to the remaining gas. Oxygen and nitrogen, for example, are valuable elements that may be collected and used for a variety of reasons. Because the process is so brief, there isn't much heat generated. To deal with rubbish, human waste, and food waste, we may build a myriad of systems and deploy them all over the planet. Graphene from captured carbon dioxide. A natural example may be found. The natural material cycle is completed when light, water, and carbon dioxide combine in plant leaves to generate biomass. In this mechanism, the metal-based enzyme rubisco takes carbon dioxide from the air and converts it into usable carbon dioxide for the plant's subsequent chemical processes. Inspired by this natural metal enzyme-based conversion, KIT researchers have created a technique for directly converting greenhouse gas carbon dioxide with hydrogen gas at temperatures as high as 1000 degrees Celsius using specially prepared, catalytically active metal surfaces. Several research groups have described a technique for separating graphene from carbon dioxide and hydrogen using a metal catalyst. If the metal surface has the proper copper/palladium ratio, carbon dioxide will be converted to graphene in a single step. In further tests, the researchers were able to create graphene with many layers of thickness, which might be beneficial in batteries, electrical components, or filter materials. The working group's next research goal is to make functioning electronic components out of the graphene it has obtained. Carbon materials such as graphene and magnetic molecules might form the basis for future quantum computers, which can do ultra-fast and energy-efficient computations but do not employ binary logic like today's computers. In terms of efficiency, chemical engineers have developed a graphene filter for carbon capture that beats commercial capture systems. Surprisingly, their filter is the world's tiniest and can extract carbon dioxide from a gas combination with more efficiency and speed than most current filters. They constructed carbon dioxide-sized holes in graphene, enabling carbon dioxide to pass through but preventing other gases, such as nitrogen, from passing through. They expect that this strategy will cut the cost of carbon capture to roughly $30 per ton of CO2 when compared to present technologies, which are 2 to 4 times more expensive.